I find that, taping it is helpful for some folks because either they might be sick that day and they miss the lecture, then I have to teach it all over to them, again, as now they can just watch the lecture and it really helps. It's really easy. And then many times I go a little fast, or many people they get home and they can't remember exactly what to do. 2 minutes on the lecture and they realize, oh yeah, I remember how to do that. And they don't have to watch the whole thing. They can just skip to whatever part they want, and it makes a lot of sense. So I am only doing it. I'm definitely not doing it, for myself. I'm doing it for you guys so that you guys have that backup. All right. So you already know the distributive property. I feel like I'm losing my voice all of a sudden.
Water.
I don't know what's going on. Okay. Sorry. Hello.
You got scared.
All right. So distributive property, if I just use variables, you just saw it just in that. But if it basically says this, A parenthesis B plus C is equal to, and I use my little arcs, AB plus AC. A times B plus A times C. A times B plus A times C. I don't know what's going on with my voice. It's really weird.
Drink some water.
Okay, so now that's with variables. Now let's use numbers, okay? And get used to using numbers for a second. If I had 4 parentheses, let's say I had 2x plus 1. Okay? That's the kind of thing you're likely to see in algebra. This is actually called a binomial. It's two numbers, or two terms. 2x is one term, 1 is another term, and it's separated by a plus sign. It's called a binomial. Binomial. So an example would be x plus 2, or 2x minus 3, or 5x plus 7. Or you could do x squared minus 1, or anything. As long as there's 2 terms, and they're separated by a plus or a minus sign, it's called a binomial, right? So those are often what you're doing when you're doing distributive properties. Sometimes you actually are multiplying times a trinomial. What do you think that would be? 3 terms. So it might be something like this. X squared plus 2x plus 1, right? Or 3x squared minus 4x minus 7, right? So all those things could be inside the parentheses. So all those things, either a binomial could be inside the parentheses or a trinomial could be inside the parentheses, right? And I am going to, there's usually something outside of the parentheses, and I have to distribute it. I have to multiply it times each thing inside. So first we'll do a binomial. I've got to multiply 4 times 2x and 4 times 1. 4 times 2 is 8. So that gives me an 8x. And then there's a plus sign, so I'm going to just put the plus sign right there. 4 times 1 is 4. I'm done. Easy, right? Easy, easy. So that was our first example. Let's do another one. What if I had negative 7 parenthesis negative 3x plus 8? Okay, again, it is negative 7 times a binomial, right? So I am going to do my little arcs to just make sure I don't forget. The classic problem, the classic mistake with distributive property is everybody multiplies this times the first term. But then they don't always multiply it times the second term. That's the classic mistake. That oftentimes, a lot of people would have said, this is 8x plus 1. Do you see what I mean? They didn't multiply the 4 times the 1. You got to multiply times everything. All right? So negative 7 times negative 3x. What's negative 7 times negative 3?
Positive 21.
Positive 21. So I just write 21x. And then what is, before I write my plus sign, when there's a negative here, before I actually write my plus sign down here, I actually think of the plus sign as part of the 8, so it's a positive 8, right? So I say negative 7 times positive 8.
Is negative 56.
Negative 56. So my negative 56 becomes minus 56. Does that make sense?
Yeah.
It always works by doing that way, except just calling them positives and negatives, and write the answer. If it was positive something, I would write plus something. If it was negative something, I write negative 56. Yes?
Say for number 1, can you just do like 8 plus 4 and then put it in front of an x? Like 8 plus 4 is 12.
No.
Then you, when the answer is, or do you have to write it like that?
You have to write it like that.
Okay.
Yeah, good question. Have to write it like that. Okay, so let's try one with a trinomial. Let's try one with a trinomial. Where are we? Okay, we're running out of time. So let's say I had 3 times negative 2x squared plus 5x minus 1.
What?
So it means I have to, this is now a trinomial that I'm going to multiply times 3. So I'm going to do my little arcs. 1, 2, 3. 3 times negative 2 is? Negative 6. So negative 6x squared. Negative 6x squared. And then I bring down my plus sign. Plus. 3 times 5 is? 15. So 3 times 5x is 15x. And then 3 times negative 1? Minus 3. Pretty easy, right? Really, really easy. Really easy. The important thing about this is you cannot solve an equation. This is not an equation, right? These are just expressions because there's no equal sign. But eventually I'm going to put an equal sign in there, and you can't solve for x with parentheses still there. You have to get rid of the parentheses. And so you use distributive property to get rid of the parentheses, right? Now, a classic problem that you will often see is something like this, that often confuses people. They'll see this, like number 4. So a classic problem would be this. Negative parenthesis 2x minus 7. And so there is a hidden number between the negative sign and the parentheses. It's always a 1, right? There's always a hidden 1 there when there's no number. So really it's negative 1 times this and negative 1 times this. So it would be negative 2x plus 7, right? So all the signs changed inside the bracket. When there's a negative outside, all the signs changed. That's a positive 2x, and now it's a negative 2x. That's a negative 7, now it's a positive 7. Okay? Now when I do this, though, I don't even worry about the 1 because it makes total sense to not even worry about the 1. I just say, well, negative times positive 2x is negative 2x, right? I just go negative times positive, right? Negative is positive is negative, so I know it's negative 2x. Negative times negative is positive, so it's positive 7. Right? See what I mean? All right. So that is distributive property. There's lots of chances to practice that on the test. I mean, on the homework, sorry.
Do we have the last 2 minutes with white friends?
Now, hang on. So I'm running out of time, so I don't want to answer any questions right now. So now we're going to talk about adding like terms. First of all, what is a like term? It's really easy. 4 and 6 are like terms, right? These are examples. So there's an example of like terms. 4 and 6. Neither of them have an x, right? You agree with me?
Yeah.
Neither of them have a y. Neither of them have a z. They're completely just plain constant numbers. So they're like terms. You can add them together, right? 4 and 6 are 10, right? I could add them together, right? Here's another set of like terms. 2x and negative 7x. Those are like terms. They both end in x. Therefore, they are alike, right? All right, another example. 3x squared and 17x squared. Those are like terms. All that means is that I have 3x squared. So this means basically this. I have x squared plus x squared plus x squared. I have 3 of them, right? And then this says I have 17 of them. X squared plus x squared plus x squared plus x squared plus x squared, right? 17 times, right? Wouldn't you know I'd put a big number there. But so there's 3 of them here, and there's 17 of them here. So how many x squareds do I have in total if I were adding them together?
4.
20, right? So 3 plus 7 is 20. I have 20 x squareds, right? X squared plus x squared plus x squared plus x squared plus. But algebra is about shortcuts. It's way easier to write 20x squared than to write x squared plus 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 x squared. Right? It'd be much easier to write just 20x squared. So if I were going to add these two together, it would equal 20x squared. Now, if I were going to add these together, plus and minus, I don't have to put a plus here because it could just be 2x minus 7x. What would that equal?
5x.
Is it going to be positive or negative?
Yeah,
Negative 5x, right? 2 x's, and then I take 7 x's away, I'm going to have negative 5 x's, right? So that would equal negative 5x. And what about 4 and 6? 10, right? So that's adding like terms. Now, if I gave you something like this, though, this is not like terms, right? If I said 3x plus 4y, those are not like terms. This says I have 3 apples. This says I have 4 oranges. It doesn't mean I have 7 apples, right? It doesn't mean I have 7 oranges. I might have 7 fruit, right? But I don't have, they're not like terms, right? They're totally different. The other one like this is an example. So I would have to, I can't do any more than that. If I said, what is that? I would just say it's that. 3x plus 4y. I can't go any further. There's nothing I can add together, join together for like terms. Now, if I did this, 4x squared plus 3x, it sort of looks like a like term, right? Because they both have x's. But it's not. Because the exponent has to be the same. Does that make sense?
Yeah.
It's got to be identical because this says I have 4x squareds. That means x squared plus x squared plus x squared plus x squared. And I'm adding to it x plus x plus x, right? Those are not the same. This says I have 4x squares. This says I have 3x's. I can't combine them. So there's nothing I could do to that, right? I'd have to leave it alone. Now, on the homework, I then combined distributive property and adding like terms like this. I might have said 2 parentheses 3x plus 1 plus 4 parentheses 2x minus 7. Right? Now, I can't combine anything until I use distributive property. But when I do, look what happens. Right? So that's going to be 6x plus 2, and then plus 4 times 2x. That's 8x. And 4 times negative 7 is negative 28. Now do I have like terms? I have 6x plus 8x, right? Those two are the same. So what would I do? What's 6x plus 8x? What's 6 plus 8? 14, right? So 14x. And then what is negative 28 plus 2? Negative 26, right?
Yeah.
Minus 26. So I'm done. See what I mean? I just combined them. I added like terms.
So in a way, it's like simplifying.
Yes,
the main problem.
exactly. That's what it's all about. So that is, so I'm going to pass out the homework.
Oh yeah.
Is it due tomorrow? Mary,
This
can
is
I
due tomorrow.
add
Yes.
something before
And
we
then
leave?
Dina has something.
Okay, so 7th graders, 2 things. Remember in the morning you filled out that sheet for when we have our guest speaker, right? You did it. So when you come into humanities, which is next, right, everybody's going to have humanities together. We're going to have a double block of humanities. Please have that sheet. You all will be sitting on the floor, so just grab a clipboard. The 8th graders will be in the desk, and you all will be on the floor with a clipboard. Shake your heads yes. Yes, no? I will collect it during reading. I'll collect all homework during reading. Okay.
So math, your homework is the handout.
Double block of humanities.
Due tomorrow.
Thanks, Gary.
Maximum bang.
All right, guys.
Thanks, Gary.
Oh,